All right, you should have graphed this y equals 3 to the x on your own. If you have not done that yet, you need to be pausing the video and doing that now. We are going to graph it this time by creating a table. In Algebra 1, we tend to do this by creating a table. In other advanced algebra classes, there are some patterns that you can use to figure it out. We're not going to worry so much about those. We are just going to create a table for now. So my table, again, these are the x values that you should use. Just plug in these 5 and we will be good. Okay, so 3 to the negative 2, y equals 1 over 3 squared, which is 1/9. Y equals 3 to the negative 1. Notice again, I'm just replacing these values. And negative exponents make reciprocals, so this is 1/3. When I plug in 0, I get 1, because any number to the 0th power is always equal to 1. This, by the way, just drawing some arrows here so you know where I'm getting these numbers. We're going to plug in 1. 3 to the 1, that gives us 3. Oops. So that's 3. And finally, y equals 3 squared, which is 9. 9. So there's my 5 points. Let's change the color again, because it never seems to work when you do it in the same color as the graph. We're going to make this one a dark. Let's do it as an orange, nice orange color. All right, negative 2 1/9. Negative 2 1/9 is really close to the axis. It's like right there. Oh, I didn't get it good enough. Try that again. Nope, cut it out. Stop it. Right about there. Close enough. Very close to 0. Negative 1 1/3 is a little bit higher. It's about right here. You can stick that one there. Stop it. Okay. This is 0 1. 0 1 goes here. Why are you so irritating? Okay, and then this one is 1 3. By the way, I'm talking to my computer, not anybody who's watching this. Unless you're watching this and you are irritating, in which case just stop being irritating. All right, then the last one here is 2 9, 5 6 7 8 9. That one's way up here. So notice that we've got this very steep curve. It grows very suddenly all of it. And there we go. All right. Again, if you had a hard time graphing these points on there, please make sure you ask your questions before you continue on to the next set of examples in which we do some of these in context. Finally, we're going to talk about here exponential growth, a very specific type of problem. And the formula that you're seeing in front of you is a formula for creating an exponential growth problem. I want to point out that if you were to replace the b in y equals a times b to the t with 1 plus r, you would get this formula that we've already talked about, right? This is a times b to the t. So all we're doing here is we're changing the way that we reflect the growth rate, okay? This is the same thing. The a is the starting point. The 1 plus r is the growth rate, and the t is time. So let's take a look at a question in context. The owner of a 1953 Hudson Hornet convertible sold the car at an auction. The owner bought it in 1984 when its value was $11,000. The value of the car increased at a rate of 6.9% per year. So let's do part A first. Part A says, write a function that models the value of the car over time. Now, I want to point out that this is increasing at a percent rate. This is how you know it's exponential. If it's increasing by a percent, this is going to be an exponential growth. So, if it's exponential growth, it means we're using this formula. Y equals a times 1 plus r to the t. And now we just need to fill in these values. Remember, a was the starting point. So we're going to read through that problem and find out what was the starting point. Where did we start with? The owner bought it in 1984 when its value was 11,000. It started at 11,000. So that's my starting value. Now my growth rate is 1 plus r. So what we have here is 1 plus whatever the percent growth is. R is the percent growth. And what that means is that I'm going to have 1 plus, now I got to be careful here because 6.9 is not the number that I want to enter into this because this is a percent. The first thing that I need to do is convert from a percent to a decimal because I do not want to put in 6.9 because that's going to make this number huge. 6.9% is a very small thing. So converting from percent to decimal is fairly simple. All you're going to do is take the decimal and move it to the left twice. So this is 0.489. This 4.89% is 0.489. I moved the decimal twice. So this 6.9%, I'm not putting 6.9 here. I'm putting 0.069. And this says over time, so the t, I don't have a specific number of years, so I'm just going to put a t there. And I'm almost done. I need to simplify this part in here, and I will have my model. And there we go, because 1 plus 0.069 is 1.069t. B, I need to, excuse me, I need to come up with a the approximate value of the car at the time of the auction. So I'm going to use this model that we just created, y equals 11,000 times 1.069. But I need to figure out what this t is going to be. How much time has gone by? Well, he bought it in 1984, and the auction took place in 2004. So how many years went by? That would be 20. So now we simply have to find out what this would be. And to do this, you're definitely going to want to use a calculator for doing something to the 20th power. There is no reason, in fact, it would be silly not to. So I'm going to pull my calculator up here. And there's a couple buttons that you're going to need to familiarize yourself with. So first of all, order of operations tells me that I need to do this part first. 1.069. And I need to take it to the 20th power. Notice that that's squared. That's not going to work real well. Notice that this one has an exponent for the variable. If you press this button, x to the y, and then type in 20, notice how it put a little caret symbol there, and then put in 20, it gives me this number. And that's the number that replaces this one here, 3.79799. So this is 3.79799 times 11,000. And again, I'm going to use my calculator for that because it is ridiculous not to. So I'm going to take 3.79. Where's my erase button? There it is. 3.79799 times 11,000. And I'm going to get 41,777. 41,799. Oops, I forgot my number. 777, sorry. 777 and 89 cents. So it's important to use your order of operations here. Do your exponent first, then multiply. All right? We're going to do one more example. This is using something called compound interest. Compound interest is a very specific application of the formula that we just looked at. Again, notice that this is exactly the same. Y equals A times 1 plus R to the T. These are the same things. I'm just putting a different letter in because they mean different things. A is the final amount, and the P is the principal amount, also known as the starting amount. So let's do the same thing as the last problem. You put $250 in a savings account that earns 4% annual interest compounded yearly. You do not make any deposits or withdrawals. How much will your investment be worth in 5 years? So A is the amount that it's going to be worth eventually. P is the starting amount. I started with 250, so I'm going to replace P with that. Then I'm going to take 1 plus my R, which R is my interest rate. And again, just like last time, we need to do this as a decimal. My interest rate is 4%, but as a decimal, that's 0.04. Remember, decimal over twice. Whoop. So that's 0.04. And it says, how much is that worth in 5 years? Well, let's find out. 250 times 1.04 to the 5th power. Bring up my calculator again, because I don't want to do that one by hand. This is 1.04 to the 5th power. And again, remember, I'm doing this part first because order of operations tells me do your exponents first. 1.21665. Now I'm going to multiply that by 250. 304.16. 304.16. That's what my final amount is, and that's in dollars. Watcha. And there we go. All right, that is the end of lesson 7.4. Head back to your Canvas and see what your book assignment is for this chapter. Thank you very much for watching, and please let me know if you have any questions. Goodbye.